Hey everyone. What you're going to end up watching is just a quick clip on a bigger video that deals with solving systems using substitution. What you're going to see is a relatively short kind of introduction into substituting a constant or an expression in one term or multiple terms into another equation. This should just give you a little bit of an understanding or a know-how of how we use substitution to be able to solve some equations. Okay, I hope this clip helps. Okay, so let's jump in. You look at question 1. Problem 1 asks you to determine 6x minus y equals 2 for each of these cases, so in each case. So let's just start examining it as we go and not really look at it as a holistic thing. So really I want you to focus in just on problem A. We have to figure out, determine 6x minus y equals 2 for when y equals 2. If we're looking at case A, we're talking about when y equals 2. So I'm hoping for us that this is just background. That is, you take a look at that and you say, well, if y equals 2, then I know that I can sub in a y value of 2. The value of y is 2, and so all we do then is sub in y equals 2. And so the process of us replacing a variable with a constant should be pretty automatic for us. Look what ends up getting created in green. You now have an equation with one variable in it, x. Now we go through and solve. And maybe you're including 6x equals 4 in your solution, but please feel free that if you put in either of those two gold solutions, that we can go straight to a reduced value of 2/3. Okay, so let's take a look at A. We had to figure out what 6x minus y equals 2 was, determine it. If y equals 2, well then that just meant we replaced y with the value it was. That ended up giving us this green equation, and in our background skills, we have the ability to solve that equation. Okay, now I want us to forget that we tackled problem A, and I want us to jump into B. We have to determine what 6x minus y equals 2 is when y equals 2x. So I'm hoping that even though y now doesn't equal a constant, it equals an expression, y equals 2x, something that can change value, we don't care. That it's pretty automatic for us to just say, well then I'm going to sub in y equals 2x. If that's the value or expression that y is equal to, 2x, then wherever I see a y, I can replace it with 2x. And that gives us that equation in green. Well, now, pretty quickly, you can just rely on, hey, that's an equation with one variable. I know how to solve that. And maybe you end up giving me that gold line. Maybe you end up giving me this gold line, but I would really love it if we had jumped straight to x equals 1/2. Okay, let's stop and just take a look at A and B now. Don't even worry about C, let's just look at A and B. In A, y equaled a constant. I just circled it in red. It never changes its value. Y is always 2. So we replaced y with the value it is. In B, y equals 2x. Now that's an expression that can change value. We don't know the value of what 2x is because we don't know what x is. But it didn't impact, it didn't change the way we could go through and deal with the problem. Well, if y is equal to 2x, then I can replace my y with 2x and now just deal with the outcome. So let's take a look at C now. Okay, in problem C, we get something just a little bit uglier. Okay, it's not a case where now y just equals something with x's or y just equals a constant. Now, y equals an expression with both. I'm hoping our reaction is, who cares? If I have to figure out what 6x minus y equals 2 is, Now when y equals 3x plus 4, we should just say, well, if that's what y is equal to, what I circled in orange, then back in my original expression, wherever I see a y, I can replace it with 3x plus 4. And so I can copy out my original expression, or equation, 6x minus, but now instead of me writing y, I can replace that with what it's equal to, a 3x plus 4, and now that's equal to 2. Now, I don't want anybody to be alarmed. If you spotted my error, that's a great thing. But I just want to address the first issue of I replaced my y with what it says it was equal to, what I circled in orange. Okay, the common mistake that I just made in that problem is common. It's going to be the one you're going to make if you make one. My original expression, if you look way back up to my original problem, said subtract y. And if you notice in green, I didn't subtract y. I subtracted the first part of y, but I did not subtract the second part of y. Because y is now made up of two things, of two terms, I have to make sure that I subtract all parts of it. So if you're asking me, the easiest way to remember to subtract all parts of it is to make sure that you put brackets around it. And some of you even learned a lesson or were kind of given a piece of advice when you were younger to say, hey, every time you substitute in, put brackets around it. Okay, I want everybody to take a look at my solution to A. I replaced my y with 2. So if I followed that advice from earlier, I put brackets around it. I just want you to notice those orange brackets really don't make a difference because I'm subtracting one term, the constant. Now I want you to take a look at B. Replace my y with 2x, so I subtract my 2x. Notice those brackets don't make a difference because again, 2x is just one term. But now I want your eyes to go to C. Can you notice those brackets are needed? So whether I choose to write that as my line or whether I choose to come in on my last green line of saying I have to subtract y, and since y is two terms, I have to subtract all parts of it, either one of those green lines are good. Notice if you then went through and expanded your brackets, you come in on my last green line. Okay, now you're just solving that equation the same way you've always solved equations in one variable. Get your variable term all by itself. Get your constant all by itself. Now we can divide out and get our variable all by itself, and there we go. Okay, the focus of where I want your attention right now is actually on that solution that I circled in blue. If you actually take a look at the situation I was given in, we solved a system. Now I could go ahead and I could label the equation I gave you in the problem as equation 1, and I could label the equation I gave you in part C as equation 2. That is actually going to look an awful lot like the systems you're asked to solve. So I want you to keep in mind that really we just solved a system, that process of taking something that a variable is equal to and subbing it into the other equation is all we're doing. Okay, keep that in mind as you're going through and you're solving your systems. That should give you a little bit of, I don't know if you want to call it theory practice, or just the fact that you can see it's that straightforward. We are substituting a value or an expression into another equation. Okay, best of luck with your practice.